Right, hi, good day everyone. So today we'll be doing June 2021 paper 2 number 1. Right, now this question, again, it's a fraction question. You can use a calculator or calculate the exact value. Otherwise, let me show you how to use a calculator. First, I will put it in red and then I'll show you how to do it otherwise, which is solving it manually. Right, so in your calculator you're looking for A, B over C button. So you're going to press this button means over, so you're going to press 1, and when you press that ABC button, this little sign is going to come up. So it's 1 over 4 over 7 divided by 2 over 3 minus 1 over 5 over 7. You put that exactly in your calculator. I'm going to do it now. 1 over 4 over 7 divided by 2 over 3 minus 1 over 5 over 7, and you are going to get an answer that looks like this, 9 over 4, which is 9 over 14, right? That is the answer. That is your way if you're using your calculator. Now, if you want to do it manually, which I don't really recommend. If they tell you to use a calculator, go ahead and use a calculator and just put the answer. Right? You don't want to spend too much time doing a question like this. But yeah, so if you're doing it manually and you want you know that you can do it quickly, right? The first things first, we always follow BODMAS. There's a combination of operations here, division and subtraction, right? The next thing is, that means we have to divide first and then subtract. That tells us the order. The next thing is we have improper mixed numbers, 1 and 4 over 7 and 1 and 5 over 7. What you will do is convert them to convert the mixed numbers to improper fractions. 1 by 7 is 7 plus 4 is 11 over 7, and 1 by 7 is 7 plus 5 is 12 over 7. So the question now becomes 11 over 7 divided by 2 over 3, right, minus 12 over 7, right? According to BODMAS, we divide first. That's 11 over 7 divided by 2 over 3. When you are dividing fractions, that division sign will turn to multiplication. So it's 11 over 7 multiply, and the fraction after your division sign is flipped. So instead of 2 over 3, it is going to be 3 over 2. So again, when dividing fractions, right, your division sign turns to multiplication, and your fraction after your division sign is flipped. Right, so it is 11 over 7 multiplied by 3 over 2. When you are multiplying fractions, always compare your numerators with your denominators. Never your two numerators or never your two denominators. It is always up and down or side to side, up or down or crisscross, never side to side, right? So what I mean by that is I'm going to look at my 11 and 7 and ask myself, is there a number that could go into 11 and 7 at the same time? No, there's not. What about 11 and 2? Is there a number that could go into 11 and 2 at the same time? No. After we finish with 11, we go to 3. Is there a number that could go into 3 and 7 at the same time? No. What about 3 and 2? No. So there are no numbers that could go into each other in this question. So what you will do is just multiply. 11 by 3 is 33. 7 by 2 is 14. So the answer for 11 divided by 11 over 7, or 1 and 4 over 7 divided by 2 over 3 is 33 over 14. Now you can convert this to a mixed number, but I tend to not like working with mixed numbers because sometimes, especially for subtraction, you have to borrow from the whole and those type of things. So it's best just to leave it like this. So now the question becomes 33 over 14, which is the first part of the question. 1 and 4 over 7 divided by 2 over 3 minus 12 over 7. Right? When you're subtracting or minusing fractions, the first thing you check is your denominators. Are they the same? Are they different? They are different, right? So you have to find LCM of 14 and 7. Again, 14 and 7 are not prime numbers, so you have to do it the long way. What the numbers that are going to go outside here are prime numbers. Let's write down 2, 3, 5, and we'll stop at 7, right? So what the smallest prime number is 2. You ask yourself, can 2 go into at least one of these numbers? 2 could go into 14, yeah, so you use 2. 2 into 14 is 7. 2 into 7 cannot. So if it cannot go into the number, you just bring it down, right? Then you ask yourself, could 2 go into 7 and 7? No. So you finish with 2. What about 3? Can 3 go into 7 and 7? No. So you go on. Could 5 go into 7 and 7? No. What about 7? Could 7 go into 7 and 7? Yes. 7 into 7, 1. 7 into 7, 1. So once you get 1, 1 at the end, my LCM would be you multiply these two, the prime numbers that you use. 2 by 7, which is 14. So you're going to put the LCM as 14. The next step is to compare my denominators, which in this case is 14 and 7, with my LCM. How many times can my denominator go into my LCM? How much times 14 could go into 14? 14 could go into 14 once. So you multiply the numerator of that fraction by 1. So it's going to be 33 by 1 is 33. How many times 7 could go into 14? 7 could go into 14, 2. So you multiply the numerator of that fraction by 2. So it's going to be minus 24. Right? 33 minus 24. 33 minus 24 is equal to 9. So my answer for this is going to be 9 over 14, which is the same thing that we got in our calculator. And this is how we would do our fractions manually. Let's look at part B. When Megan started working, she was paid $85 each week. So that first statement means 1 week is equals to $85. So $85 is equal to 1 week, whatever you want to put. After a 6-month probation, her probation period, her pay was increased by 20%. So increase is equal to 20%. How much was she paid each week after the increase? First off, this is percentage change where you have an increase in percentage. Your original or before any increase or decrease is always how much? So this 85 is actually equal to 100%. This is before any increase or decrease in percentage. So basically they're telling you for her what is after the increase. If you have an increase, you have an increase in percentage. So her new pay in percentage would be 100, which is her old percentage, plus 20. So we want to know what is 120%. That is what we're trying to find out for. I tend to, now there's a formula that you can use. I don't like teaching formulas. I like to teach the if, then, and therefore. If you could avoid the formulas, we do that. All right. So again, there's if, then, and therefore. Right? And your if, then, and therefore, there's your left-hand side and your right-hand side. Your right-hand side tells us what we're trying to find out. We are trying to find out how much she's paid, which is dollars. So dollars is going to be on your right-hand side. Right? And your if line is what is given. So what we know is 100% is equal to 85. So $85 is equal to 100%. Right? Then is to always find for 1, unless your first line is what 1 is equal to. 1% would be, again, right-hand side divided by left-hand side. You're going to look at your if line. What is on your right-hand side on your if line? 85. What is on your left-hand side on your if line? 100. So it's 85 over 100. And therefore, now if we find for 1, we can find out for any amount. So therefore, 120% would be how much ever 1 is equal to, which is 85 over 100 multiplied by 20 over 1. Right? And you put this in your calculator. 85 over 100 multiplied by 120, which is equal, hold on, that is, right, When you do this, you're going to get her new payment is $102 every week. So how much was she paid after the increase? She was paid $102 every week. Part C. Part C, you already seen significant figures, standard form, percentage increase, right? So let's read the question. In 1965, the population of country A is 2,714,000. So let's write that down. 1965 is equals to 2714 with 3 zeros, right? And 2015 is equals to 3,663,900, right? So your increase would be, they ask you what, oh sorry, no, we're not jumping the gun. Write the population in 2015, which is 3,663,900, the three significant figures. Now, with significant figures, let's put 3663900. We always start from the first number. So that would be 1. This would be one significant. 3 would be a first significant figure. 6 is the second. The second 6 is the third. The second 3 is the fourth. 9 is your fifth. 0 is your sixth, and the next 0 is your seventh. They ask for 3 significant figures, so you're going to draw a line after your third significant figure. Anytime you draw that line, you are checking to see if the number after the line is more than 5 or less than 5. It is less than 5, so you do not have to add 1. This number will remain as is, so it is going to be 366, and everything after the line will turn to zeros, so it will be 0, 0, 0, 0. And this would be your answer, 3,660,000, right? And always, guys, if you have it to significant figures, how much ever significant figures, you're going to put to 3SF. You are telling the examiner, whoever is answering the question, that my answer is the 3 significant figures. Right now, let's write the population in 1965, which is 2,714,000 in standard form. Again, the aim in standard form is to get one digit that is not 0, right? You want a digit, a single digit, 1, 2, 3, 4, 5, 6, 7, 8, 9 in front of your decimal. So we're going to shift it. 1, 2, 3, 4, 5, 6. So we shifted our point 6 times, and our decimal is now between the 2 and the 7. So it's 2.714. You can put the 3 zeros, it doesn't really matter, right? Multiply, it's always multiply by 10. And because we shifted to the right-hand side, that is not right-hand side, sorry. Because we shifted to the left-hand side, your power is positive. And how many places did we shift it? I just now counted, it was 6 times, so it would be positive 6. If it was shifted to the right-hand side, it would have been negative, right? So your answer for this would be 2.714 multiplied by 10 to the power of 6. You do not need to put positive in front of that 6. Is understood, right? The next question is, determine the percentage increase in the population from 1965 to 2015. They want the increase. So we know, and I'll just write it down, in 1965, your population was 2,714,000, right? And then in 2015, your population was 3,663,900. So how much it increased by, right? Your increase would be a larger number, 3663900 minus 2,714,000. Right, so this would increase by, let's subtract it, 3663900 minus 2714 and 3 zeros, yeah. When you subtract this, you will see that your increase, I don't want to put the answer right, would be 949,900. This is how much it increased by. Again, we're doing percentage increase, so we are going to do if, then, and therefore. What was your original before any increase? What was your population before any increase? Right, so your original or before your increase is always 100%. So we know that 100% is equal to 2,714,000. We want to know how much is 949,900. So we again, if, then, and therefore. If, then, and therefore. We know we have the left-hand side, right-hand side. Right-hand side, it tells us what we're trying to find out. We're trying to find out percent, so right-hand side is percent. Your if line is what is given, right? We know that 100% is equal to 2,714,000, right? Your then line is to find for 1. 1 is your right-hand side divided by your left-hand side, which is 100 over 2,714 and 3 zeros, 2,714,000. And we're trying to find out what percentage is this. So 949,900 would be equal to 100 over 2,714 and 3 zeros. All right, multiply by 949,900 over 1. All right, so let's see, multiply by 100 over 2,714. Right, when you do this on your calculator, you're going to get an answer of 35. So what was the percentage increase? 35%. There is another way you could have done this. You could have found out what percentage is 3,663,900, and then you just subtract the percentages. Right, I'm assuming that this would have been 135%. 2015, the percentage would be 135, and then you subtract the 2. Right, and that is how you would do this question. Last question now. To part D. Part D says the ratio of teachers to male. So they're telling you the ratio is teachers to male to female students is 3 to 17 to 18. So the order in which they give the ratio is the order in which that they would give the ratio itself. If the total number of students would be what? Males and females, right? In the school is 630, determine the number of teachers. So when we're talking about ratio, we understand it as parts. So it's 3 parts to 17 parts to 18 parts. Now they told you we're talking about the total number of students. Number of students in parts, so the number of students in the ratio parts would be 17 plus 18. And 17 plus 18 is what? 17 plus 18 is equals to 35. So they are basically telling you, oh, hold on, I don't know what happened there. 35 parts. So they are basically telling you that 35 parts is equal to 630, and then you have to find for 3 parts. Right? Again, if, then, therefore, if 35 parts is equal to 630. Again, my right-hand side is what I'm trying to find out. We're trying to find out the number of persons. So that is why persons are on your right-hand side. Your left-hand side is here. So if 35 parts is equal to 630, then 1 part would be 630 divided by 35. And therefore, we're trying to find out for how many parts? 3 parts, which is the number of teachers, right? So 3 parts would be, if you know 1 part is 630, 630 divided by 35, and you want to find out 3 parts, you just multiply by 3. Right, so let's do this on the calculator. 630 divided by 35 multiplied by 3 is equal to, so the number of teachers will be equal to 54. So how many teachers? There are 54 teachers. And that is how you would do this ratio question. Right, and this is the end of May, June 2021.